Alrighty, good morning. So today we're going to be talking about ABGs and trying to give you a little bit more information on how arterial blood gases are looked at and analyzed. So we have our normal ABGs, which have a pH around 7.4. Now there's a range of that, 7.35 to 7.45. All that is in the range of normal. And as long as our pH is in that range, then our blood work, as far as acid base, is going to be more copacetic for the patient. The patient works better, drugs work better, the oxygen hemoglobin dissociation curve works better when we're in a normal pH, which is around 7.4, and it can range a little bit to either side, 7.35 to 7.45. Okay, so if we're out of range, and we're out of range low, 7.3, 7.25, 7.2, all that's on the acidotic side. If we're on the high side, 7.5, 7.55, 7.6, now we're on the alkalotic side. And as we've talked about on the oxygen hemoglobin dissociation curve, when you're acidotic, it shifts right, and so it will offload it'll take more PO2 or more PaO2 in order to load up the hemoglobin, in order to load it up, because it has a decreased affinity. Decreased affinity when it shifts to the right, but it offloads at the tissue level more readily, better. We'll use better. That's a shift to the right. If it shifts to the left, now you're alkalotic. That's alkalotic. This is acidotic. And it has an increased affinity. And it loads up easier. Easier, that's spelled wrong, easier, and it will not offload, has a decreased offloading because it wants to stay on that hemoglobin molecule. So one of the main reasons drugs work better if you're normal pH, tissue oxygenation, whether it offloads at the tissue level, has to do with ABGs and where we are on our acid-base status. So when we look at our ABGs, we have normal ABGs down here. We have a pH, we have a CO2, and we have a bicarb. We're not talking about oxygenation right now, we're just talking about acid-base balance. 7.4 is right in the middle of the normal range. CO2 is right in the normal range of CO2. Normal range 35 to 45. Normal middle of the range is 40. Bicarb, same way. Normal is about 24. There is a range, could be 22 to 26, 22 to 28, depending on what book you're looking at and whether it's Egan's or it's Desjardins, but they're all in the mid-20s. So when we're looking at the CO2 is acid. The bicarb is base. It's base. Base. Acid. Acid and base. They balance each other out, and that's why it's called acid-base balance. Acid-base. You want the acid and base to equal each other out, and we have a normal pH. So when we're looking at it, we are seeing where are we off. Is it because we have too much acid, or is it because we have not enough acid, or vice versa, not enough base, too much base? And so we'll take a normal blood gas. So we'll take a blood gas that is acidotic. I say a normal blood gas. How about a 7.2 for pH? And we have a CO2 of 60, and we have a bicarb that's normal. when we analyze that, we say we have a acidotic blood gas caused by too much acid, too much CO2, and it has not had, the bicarb has not had any chance to compensate for that pH being out of the normal range. It's gone to the acidotic side, and the body is going to try to hold on to bicarb to bring this pH back into normal range. But it takes between 48, 72 hours for the body to hold on to bicarb in order to balance out this CO2 and bring this pH back. And if we were to analyze this gas, we would say this was an acute acidosis. Acidosis. Acute acidosis. Why? Because the body has not had a chance to balance this out and bring the pH back into the normal range. It's an acute acidotic condition. So when we're looking at the different things, we have different ways of looking at acidosis. We can have acute acidosis, we have partially compensated acidosis, and we have fully compensated acidosis. What does that mean? In partially compensated, I'm just going to write PC, partially compensated, going off the screen here, but partially compensated, what will happen is this bicarb will go up. It'll try to compensate for that high CO2. It'll hold on to base to balance out the acid. And little by little, this pH will come back into normal range. It'll go back to 7.2, 7.3, 7.36. It'll eventually come back into range. And when it comes all the way back into a normal range, even though the CO2 high, if the bicarb, say, goes to 30, make it 30, and the pH comes all the way back into normal range, 7.36 will be right in here, 7.36 is back in the normal range, we would say that would be fully compensated, or a chronic condition. A chronic condition takes time in order to occur, and it takes time in order for it to balance out the acidic. We see this in COPD patients where the CO2 has been high for a long time. The bicarb has gone up because the body's trying to compensate for that acidic condition. It'll hold on to bicarb, and now the patient will come all the way back into a normal pH range, even though the CO2 is high and the bicarb is high. We call that fully compensated. Compensated or chronic. Compensated or chronic. That is when your pH is in the normal range, both your CO2 and your bicarb are out of range. We can also do that on the alkalotic side, where we can have somebody who has a very low, they have a low bicarb. I'm going to erase this, and actually I'm going to work, see if I can find a little spot here where I can work on this. That's to work in this section right here. I hope you guys can see this. So if my pH is 7.5, it's alkalotic. The reason it's alkalotic is because my CO2 is normal, but my bicarb is really high, say 30. Now I'm alkalotic. I have an alkalotic blood gas. Because my CO2 is normal, my bicarb is elevated, my pH is out of the normal range, I have an acute condition. It's acute alkalosis. And since it was not caused by the CO2, it's caused by the bicarb, that's actually a metabolic condition. Acute metabolic alkalosis. So we can have an acute condition in alkalosis, we can have an acute condition in acidosis. And as I go into further videos that I make for you, I'll explain more, but this is enough for right now to get you started, and then I will see you on the next video. Thank you very much.